Okay, we will continue with next presenter, ID 87, from Prof. Basim Abu-Jdayil, yeah, on dead pump surface fibers as a green thermal insulator. Okay, let's welcome Prof. Basim. Prof. Basim, unmute.
Lobna, can you please make Prof. Basim a co-host to be able to share?
Yeah, I want to share my screen, please.
Yes, now you can share your screen.
Okay. Can you see my screen?
No, not yet.
Yeah, now?
Yes, now.
Okay, thank you very much. Okay, Assalamu alaikum, everyone. My name is Basim Abu-Jdayil. I'm a professor at in the Chemical and Petroleum Engineering Department at United Arab Emirates University. Yes, our topics today, actually, the whole topic is about the date palm, actually trees and date palm fibers. Okay, we will share with you our simple experience actually here with this date palm wastes that we have it in UAE. Okay, but now I will go to another application, maybe which is now the what we call it the thermal insulation actuator or green thermal insulations. Okay, now okay, I can move. The motivation is very clear actually for thermal insulation systems. Okay, in the Gulf region in general, we have actually harsh environment. The energy actually here, consumption is very high. Most of this energy consumption is in buildings, especially in UAE. Now, based on the classification, maybe we can classify the Gulf regions and UAE, especially actually here, it is one of the highest actually here energy consumers, okay, in the world, at least per capita. Therefore, we need to find some actuator means to reduce actuator this energy consumption. One of the main actuator methods that we use actuator the thermal insulators in wide range in buildings everywhere actuator when it is actuator it is applicable. Now, we have actually, that here different insulation materials in the market, like, for example, polyurethane or polystyrene or mineral wool. We have actually here many with acceptable thermal insulation properties, but still they have actually here some drawbacks actually here and concerns on these materials. One of them, it is actually here the mechanical properties of these materials is relatively high. Now the impact or the what we call it now actually here CO2 emission actually here related to production of these materials is relatively also high. In addition, actually these materials in general, okay, they suffer from what we call it actually here health problems related either to respiratory systems or actually here other health actually here problems. Therefore, we have motivation actually here to produce green thermal insulators, biodegradable actually here thermal insulators, okay, based on the available natural materials or waste materials. طبعا here if you utilize such kind of natural resources or natural waste actually that we have it, then this will have two actually here advantages or impacts actually here on the environment by reduction of CO2 emission. And in addition, this is possible also to reduce actually what here the cost actually here of these materials. As you know that here in UAE actually here we have a lot of date palm trees. They generate actually what here a lot of waste. Then we have another problem, which is now actually here, the waste management actually here of these actually here date palm waste in different terms. Approximately we have 40 million trees actually here in UAE. Each tree per year it produced about 15 kilograms, which means that here we have more than 500,000 ton actually here of this waste actually produced annually without real utilization actually here for this waste. I will share you here actually here two approaches. Okay, we have actually here many approaches to utilize such kind of waste, especially now actually here in the production of thermal insulation materials and composite materials in general. One of these approaches is we try actually here to use the date-bound surface fibers directly, okay, to produce some kind of thermal insulation materials. We have to avoid actually have to use some kind of chemicals or toxic materials. We try to use now non-toxic materials like polyvinyl alcohols actually just as a binder for these materials, and try to produce some kind of date-bound actually or date-bound based now thermal insulators. And we have simple procedure like, for example, collecting these surface fibers, cleaning actually drying to avoid actually or to reduce the moisture content. Then we have prepared the PVA solution with a specific concentration after many experiments. Then we soaked actually these fibers actually in this solution, take it actually to the hot press or the hot press machine actually here, and we try to form actually here our samples at relatively low temperature. Low, I mean that is not very high. It is about 70 degrees centigrade for 3 hours under certain load, which is about 3 tons. Okay, and then we try to get actually here different densities from these fibers to see that actually here the effect of the density of the fiber or the fibers produced or the boats actually here produced on the properties that we need to test it. We get out with 3 samples or 4 samples actually here with different densities ranged from about 203 to about 254 kilogram per cubic meters. These are the samples that we have produced. And then we tried actually here to test it for different properties. I will show you some properties actually here, or some main properties that we are interested in. Like, for example, the thermal conductivity. You see that here, how the thermal conductivity or the range of the values of the thermal conductivity of these produced insulators actually. We see that here, this is most likely they are below 0.05 watt per meter Kelvin, which is in the same range actually here of the traditional thermal insulators, okay, which is usually it is 0.05 and below. If we check actually here the thermal diffusivity, we'll find that here the value it is in range 0.137 to 0.147 or 0.15 actually, which is again it is a little bit actually here less actually here than the traditional thermal insulators, which means that here in terms of these properties, now our material it is what it is a good competitor actually here with the traditional thermal insulators materials. If we talk about the tensile strength actually of these materials, we found that here we can with these fibers get actually here till about 10 megapascal, which is again much higher actually than the traditional thermal insulators materials. The modulus it is relatively high, which it can reach between 300 and 400 megapascal. Okay, which means that these materials also it has enough toughness actually. Okay, and can be now used actually in construction material with minimum loss comparing with the polystyrene or expanded polystyrene, where usually in the construction materials they have actually, or construction application, they have a lot of losses due to the low actual here mechanical properties for these materials. The main actual here disadvantage or drawback for these materials is actually here the water retention. Where you see that here, this is the test for the water retention, where now the water absorption or retention, it can reach about 100% for these actual here fibers, okay, which is relatively high. And this is actually here, the research should be focused actually here on this point, how to actually here to reduce the moisture actually here absorption or water absorption of the date-bound fibers in general to be used actually here extensively in different applications. The second actually approach that I will share with you, which is now in terms of composite materials, where now we need to produce again here or utilize the date-bound fibers in green actually here composite materials. Therefore, we have selected the polylactic acid as the polymer matrix. We mixed actually here with the different actually here percentage of date-bound fibers. Okay, from 10% to actually here used 50%. Now we mix it through the melt extruder, then we put it in the specific molds based on the property that we need actuator to test. Then we make the final shape actuator in the hot press. Okay, we applied a certain annealing process for this system to produce finally different actuator products, as you can see in the last actuator image. If we check now some properties together quickly, inshallah, then we see that here actuator we have the density of the produced material. It's in the range of 1,200 kilogram per cubic meters, where actually the experimental density, it was a little, or it is higher than actuator the theoretical density, which is calculated from now actually the simple actuator linear mixing rules. Okay, طبعا we have different actuator يعني maybe reasons, but we think that here the main reason is that here during the melting process, during the now the extrusion process or parts actuator, the date palm fibers lost actuator some of their volatile materials. Therefore, actuator the actual density actuator it is higher than what we have it actuator as raw or fresh actuator parts. Here we have the properties of the thermal conductivity. As you see that here, now the addition of these fibers reduce the thermal conductivity of the BLA in general, where we are relatively in good range. If we move down, after a certain percentage, which is above 30%, then we have some actuator slight increase again of the thermal conductivity. We see that here, if we make it now the theoretical validation, we see that here, our most of the data actually they can be fitted by what we call it the series conduction model. Okay, where now in this model simply here, we assume that here the particles are well dispersed at a high filler content. We see that here we have deviation from this model simply because now we expect that we have some kind of agglomeration actuator for the date palm fibers. Okay, or now this is actuator in small size, which is now less than 200 micron in general, which means that these particles they agglomerate actuator together to deviate actuator from symbol now as what we call it the series conduction model. But still now here, the value of the thermal conductivity is relatively low and it is acceptable for actuator thermal insulation applications. Other actuator thermal properties like CB and thermal diffusivity, as you can see here also, the alpha here or the thermal diffusivity it is very, very low and it is much lower actuator than the traditional thermal insulators, which is it means that here my material it can be a real real candidate actuator for thermal insulation applications. Water absorption, you see that here, the water absorption actually for this composite material is relatively low, which is now in many actuator cases it is less than 2%, even in hot water it is less than 3%. Okay, but here we took the advantage of the BLA, where the BLA actually in general, okay, it is hydrophobic material. Okay, in general we can say it is hydrophobic material. Therefore, the water absorption it is relatively low and it is what in the acceptable region. If we check the water immersion for long term, actually here, we found that here our material, when put it in water for long term, weeks actually, we found that here our material starts to crack after maybe 2 weeks. After 2 weeks starts to get some cracks. Now deterioration if the samples after actually here 6 weeks, and sure that here the damage or deterioration in the samples appears with the samples with high filler content in general. Here we have the compression strength actuator properties. Usually we know that here the adding or incorporating actually the natural fibers in polymer matrix, it will reduce actuator in many cases, it will reduce actuator the mechanical strength of the material. But here we have the same trend in general, but the reduction here, it is acceptable. If we talk about 30, 40, 50% actuator of date utilization of this date fiber, actually, we see that here, we have a good actuator mechanical strength. It can reach to about 60 megapascal, which is much, much higher actuator than the mechanical strength of the now traditional insulators. But and at the same time, it is in the same range of what? Of the compression strength actually of what? Of the now of the construction materials. Therefore, now here, the chance for this material to be used actually here in construction, it's relatively high. Other properties like modulus and strain, it was slightly affected actually here by the addition of date palm fibers, and is still actually here in good range and in the acceptable range. But if you inspect now the microstructure, we found that here still we have clear interface between the fibers and the polymer matrix, where these actually can be the source or starting point actually here for the cracks, which means that here the research can work actually here on this point to actually here reduce actually here this gap, okay, and actually here enhance even the mechanical process of our system. In general, we can say that here we can develop actually insulation materials from lignocellulose waste, as we have seen for the palm fibers, with promising actually here results either in terms of thermal conductivity, water retention, or actually here the mechanical strength. Nowadays, actually here we work on two main actually here things, which is now to actually enhance the compatibility between these fibers and the polymer matrix. Specifically now we talk about biodegradable materials, and we try also to work on the hydrophilic nature actually here of these natural fibers, again actually here to improve the thermal conductivity, since it is function of the moisture content in general. Therefore, application of different modification or chemical modifications or surface modification methods actually here on these natural fibers, sure that it will improve these properties, or actually here their application in different actually here aspects. Thank you very much. Yeah.
Thank you very much, Prof. Basim, for a great presentation. Very comprehensive research on date palm as the thermal insulator. Yeah. So I would like to open maybe one or two questions from the floor only. We have like 2 minutes. Is there any question? You can raise your hand if you have any. No?
Okay, so if I may ask one question. Thank you so much, Prof. Basim, for this very insightful presentation and extensive research. MashaAllah, congratulations on this work. You know, as I said, I come from a textile background. I believe that having some sort of textile processing for making those kind of thermal insulation would create a more, you know, industrial version of those material. I mean, there's a very specific technique that we use for making the thermal insulation bats that are commonly used nowadays with the linen or flax or even hemp fibers, which follows like a carding method or a dry laying method that is then blended. The fibers are blended with the specialty we call springy fibers, bicomponent fibers, that provides the high loft for the thermal insulation bat, and also it's mixed with a low melting polyester fiber, and then it goes into, after the carding and the laying of the bat, it goes into like an oven, so that only the low melting temperature polyester fibers melt, and it binds together the natural fibers to give some integrity to the like non-woven insulation bat. So this is one thing that perhaps could be considered, like the textile processing. Thank you so much.
Yeah, thank you very much, Dr. Muhammad, for your comment. Yeah, I said that we have different actuator approaches, and this is one actuator of the things that we recently we have considered. Okay, which is now again, but now the problem that we focus actually mainly on the biodegradable actuator polyesters. We don't need to go to back actuator to fossil-based actuator polymer materials. But this is actuator, it is considered, and I have now master students actually, they work actuator in this area. Okay, which is now we try to get fibers, make some kind of coating with actuator biodegradable polymers. We considered BLA, we considered the BHP, Okay, these Actuator materials, but this is very interesting. Thank you, Dr. Mohammed.
Very interesting. Prof. Kais, very short question or suggestion. Welcome, Prof. Kais, for a question.
Thank you very much. Thank you very much, Professor, for to share with us your knowledge. I have just a question about the thermal stability of the fiber when we use the extrusion process with PLA and fibers. How about these? As you know, the natural fiber it's difficult to use the extrusion because the degradation is around 200 degrees. Thank you, Professor.
The degradation temperature, Professor.
We have noticed Actuator this problem, okay? Especially now when we get Actuator, the density Actuator properties, and we compare it with the density actually of the, with the density, with the theoretical density actually. Now, as we said that here, we try, the problem with that, with the melting, that it is, yes, it is in the range of 170 degrees centigrade. When we make the TGA, we found that, yes, now the degradation a little bit starts, which is a little bit with less temperature, with 150, maybe 160, it depends actually on the source actuator of the fiber. Okay, therefore now we have, we try to search actually for other methods. And now currently actually also we have students, they work actually to compare between different methods, which means that here with for example, just actually hand mixing, for example, with the fibers and go directly to the hot press, or now with the extrusion, what will be the difference now? Okay, to see that here, yes, is there big difference? It is really, we have damaged actually here the fibers, and we don't actually benefit a lot from these or not. Yeah, this point actually,
maybe Prof. Basim, you can share your textbook. Do you have research book, Prof. Basim? Share with us.
No textbook. No, not yet, but maybe later with the cooperation with our colleagues here, okay, we can produce textbooks. Okay, we focus now actually here on the papers rather than the books.
Okay. Thank you very much, Prof. Basim, for a very interesting presentation. We may